Here's a domain and range application problem. Height in meters with respect to time in seconds of the cannonball shot at an angle of 45 degrees is modeled by the function h of t equals to minus 5t squared plus 19t plus 4. Determine the domain and range of h of t. Okay. Now it's a quadratic equation. We know domain is all real numbers because it's a quadratic equation, right? But in practical cases, what happens is we take t as greater than or equal to 0. We cannot take t as negative. Second, when we have a problem like this, so it says that cannonball is shot at an angle or something, right? Then it goes like from a height of, when t is 0, its height is 4. So it goes kind of like this, follows a parabolic path. Now as soon as it strikes the ground, the parabolic path is lost, right? So for practical reasons, our domain really is from 0 to this value of t, correct? So that's the domain. And the range is, we need to find the maximum height of the ball. So once we find that, then we know domain and range of the function, right? So to find the maximum height, we can do completing the squares. And with our knowledge of quadratic equation, we know minus b by 2a actually gives us the vertex, right? But let's do completing the squares and then get our answer. Okay, so h of t here is equals to minus 5 t squared plus 19t plus 4, right? So which means we'll take minus 5 common, and so we get t squared plus 19 over 5. I already made a mistake here. It should be minus because we took minus 5 outside, correct? And we'll leave this 4 as such. Now, what is the next step for completing the squares? We have to take half of this term, square, add and subtract that term, right? So we get h of t squared minus half is, we'll write this first, 19 over 5, and then we write plus 19 over half is 10, okay? Square minus 19 over 10 square. So that is like half of this we have taken, squared it, and added and subtracted the same term. So it makes no difference, right? It's like kind of adding 0 plus 4, correct? Now, these three terms form a perfect square. T minus comes from here and the term 19 over 10, okay? And then we can write square of this, which is 19 square, or 1.9 square I can write here, like 1.9 square, bracket close, plus 4, correct? So we can write this as minus 5, open the brackets, we get t minus 19 divided by 10 is 1.9 square minus. So we can do square of 1.9, so we get 1.9 square equals to, in decimals, 3.61. So we can write this as 3.61 times minus 5. So, okay, let me write like this. So we get 3.61 times minus 5. Because when you open the bracket, you have to multiply minus 5 with both, right? Plus 4, correct? So let's multiply 3.61 times 5, and we get, in decimals, 18.05. So I will write minus 5 times t minus 1.9 square, minus minus becomes plus, and when I multiply 3.61 with 5, I get 18.05 plus 4. When you add them up, you get your vertex, and the vertex happens to be at 1.9, right? Plus 22.05, correct? So that's your vertex, and we say this vertex actually happens at t equals to 1.9, correct? And the height is 22.05. So write this as 22.05. Okay, so that is how we can find. Now the range is clear to us, that the range is less than equal to 22.5. Okay, to find this time, when will it be 0, what we can do is we can equate h of t as 0 and then find the value of t when the height was 0, right? So we say 0 equals to minus 5t square plus 19t plus 4, correct? Or let's bring them, I would always like to put this number positive, right? So I'll write this as 5t square minus 19t minus 4 equals to 0. Somehow I feel that keeping this positive makes things simpler. So now from here, using quadratic formula, I get t equals to minus b, minus of 19 is 19, plus or minus square root of 19 squared. So we'll do 19 squared. 19 squared gives me 361 minus 4 times a times c. So minus and minus becomes positive, right? Because we are doing minus 4 times 5 is 20, 20 times 4 is 80, right? But minus minus becomes plus, so we get 80. Over 2 times a, which is 2 times 5, which is 10, okay? So let's add 80 to 361 and find the square root. So we do plus 80 equals to 441, and the square root of 441, right, equals to 21. So we get this is equals to 19 plus or minus 21 over 10, correct? So if we do minus 21, we get a negative answer, or which is not a valid answer. So we'll do plus 21 to 19, and 40 divided by 10 gives me 4. So the time when it strikes the ground is t equals to 2, correct? So from here we get that the domain is from 0 to 2, correct? And the range is from 0 to 22.5, correct? So now we can write down our domain range. That is the answer, right? So we say now domain is equals to t is greater than equal to 0 and less than equal to 4, and the range is where t belongs to real numbers. In minutes it is, right? So we can write like this. Better to write like this, right? Range, we say h of t belongs to real numbers where it is between 0 and 22.05, correct? Okay, I should have written this also in this form, but I hope you get what I'm trying to say. So t is all real numbers between 0 to 4, correct? And this was 4, not 2. 0 to 4, and range is from 0 to 22.05. Remember one thing, that for a parabola normally domain is all real numbers, but in all practical applications you have to look for valid values, right? For example, here t cannot be negative, and once the ball strikes the ground the equation is no more valid, right? So this equation is actually for the ball in air, right? Once it hits the ground the equation is not valid. Therefore we take t as domain as 0 to 4, correct? Okay.